Hello, everyone, and welcome to The Vertical Space, a podcast at the intersection of technology and flight. We are your hosts, Jim Barry and Luka Tomjanovic, and here we look at the most important forces shaping the market of advanced air mobility, with a particular focus on why and how they matter to those building a business in this very exciting and growing industry.
Consumer, you can spend $50,000 on an automobile and get just an absolute marvel of technology. But in general aviation, you would spend 10 times that much and you would get 50-year-old aircraft design with a 75-year-old power plant. And why you don't have the kind of technology leaps that we've seen in automotive.
Hey, everybody. Good to have you back with us. And I think you're really going to enjoy this podcast. Few have Mike Whitaker's background and senior executive experience in both aviation and in automotive air mobility. Mike speaks with authority and experience as the former Deputy Administrator and Chief NextGen Officer of the FAA, Group CEO of India's largest travel conglomerate, a senior executive at United Airlines, and now a senior executive at Supernal, Hyundai's urban air mobility subsidiary. Mike discusses the transition from today's air transportation system with its remarkable safety record to discussing what is required to transition to advanced air mobility. It's a fresh perspective with a firm grounding on what will have to happen to get it right, be profitable, and safe. Enjoy the podcast.
This episode of the Vertical Space podcast is brought to you by UAvionics. UAvionics is the leader in low size, weight, and power certified avionics for manned, unmanned, and advanced air mobility aircraft. Let UAvionics help you achieve your goals, whether that be type certification, airspace access, or beyond visual line of sight operations. UAvionics has certified and certifiable communications, navigation, and surveillance avionics for your aircraft. So head over to uavionics.com or Google it to see how you can start flying safer and move your platform forward into shared airspace.
It's a great pleasure to have Mike Whitaker on our show. Mike has spent his career in aviation, first as a lawyer for TWA in New York and Washington, then working for 15 years at United Airlines in Chicago, where he rose to Senior Vice President of Alliances, International and Regulatory Affairs. In 2009, he left United Airlines to become Group CEO of Interglobe Enterprises, India's largest travel conglomerate and operator of Indigo Airlines, based in Delhi. After returning to the U.S., Mike was appointed by President Obama in 2013 to serve as the Deputy Administrator and Chief NextGen Officer of the FAA, where he was responsible for the modernization of the air traffic system and worked closely with the Administrator Huerta in running the world's busiest, most complex, and safest air traffic control system. Mike left the FAA in 2016 and spent several years advising airlines and aerospace companies. He now heads global policy for Hyundai's urban air mobility subsidiary based in Washington, D.C. Mike, a private pilot, earned his law degree cum laude from Georgetown University in Washington, D.C., and holds degrees in political science and French from the University of Louisville. Welcome, Mike. It's great to have you with us.
Thanks, Jim and Luka. Great to be here.
So, Mike, we generally like to start with one question before we get into the meat of the questions. Is there anything that very few in the industry agree with you on?
Well, Jim, I think there's actually a topic that very few in the industry agree on, even among themselves. And I think that's the timing of when this technology will be ready for prime time, if you will. You've got several startups that are looking to launch in 2023, 2024. Some people think that's ambitious from a certification timeline. But even if you assume certification, the infrastructure is not going to be very mature at that point. So you won't have a network of vertiports. The operational rules will be the traditional IFR, VFR rules. They're not necessarily up to speed for this type of operation. And then there are some people who think that this won't be ready for 20 or 30 years, that this is just a pipe dream and we've heard it all before. So I think I fall somewhere in between those two extremes. I think it's not as far away as some people think. I think by the end of this decade, we'll see quite a few advanced air mobility, electric vertical takeoff vehicles in operation and available for service. And then we're going to really see this industry mature over the decade of the 30s going forward.
Mike, how does this assumption of timeline impact or influence product design or business models?
Well, I think on the product design, battery technology is really the big key to these vehicles having a business model available for them. So battery technology is improving gradually. It doesn't improve the same way that computer chips grew exponentially. It's more of an iterative improvement. And right now, I think we're really barely in that place where you can build a vehicle that stays in the air for 30, 40 minutes. It's really a challenge. I think by the end of this decade, that piece will be less of a challenge. On the business model side, you need that infrastructure that I was referring to make it work. So you could envision a number of use cases, but if you just think about downtown to the airport, you need vertiports in cities, and you need air traffic control routes that get you into the airport space, and you need a facility at the airport to disembark passengers or load passengers, preferably on the other side of security or some way to navigate the security issue. Airports don't add facilities very quickly. So I think we're really a long way out from having that type of infrastructure in place and the operational rules in place to make a robust business model.
Okay. So Mike, one thing that caught my attention in your bio is that you ran FAA's NextGen program. And for those who are not familiar with NextGen, it is a broad and ambitious effort to modernize the U.S. air transportation system with a combination of technologies and procedures and policies and others. I wonder, how does advanced air mobility fit into NextGen, or will there be a need for, call it NextGen 2.0?
Well, I think NextGen's a little bit of an unfortunate name because you never quite get to the NextGen, but the air traffic NextGen program was really focused around migrating from a radar-based system to a satellite-based navigation system. And that piece of it has been complete. A lot of the other elements of NextGen just sort of got added on over the years. But I think the heart and soul of it was that ADS-B technology, the satellite navigation technology. I think what's interesting about that program, as I got to see that at FAA, is how long it takes to introduce new procedures or new technologies into the national airspace, the NAS. And for obvious and very good reasons, there's a huge amount of testing that goes into that, really a certification process to introduce the new technology so that you don't harm the incredible safety levels that we have in the air traffic control system. U.S. system is enormously busy and unbelievably safe, and nobody wants to upset that dynamic. So I think when you look at advanced air mobility, we will need new procedures. We'll need some new rules. So you could operate in the existing rules. You could have a pilot on board, and the pilot can talk on his radio and have a transponder and go in the traditional aviation pathway, if you will. But for the business to work, ultimately, these vehicles are going to be autonomous. And you will want a situation where the vehicle is being monitored or controlled from a pilot on the ground who might be overseeing the operation of 3 vehicles or 5 vehicles or 8 vehicles. It's a process to get there, but you can imagine those steps involve a lot of new technologies being deployed in the NAS and a lot of testing to make sure that they're safe and a lot of education for the general public and the regulator to trust that transition to autonomous operations.
Yeah, I think that is definitely part of that infrastructure challenge. If you think about routine operations of these eVTOLs in urban environments or even intra-urban environments, and the kinds of changes that you might need to do to the airspace structure to real-time dynamic arrival and departure procedure updates and changes, and perhaps even creation. Not to mention maybe even a new set of flight rules.
I think that's right. You want to, we've got visual flight rules, VFR, instrument flight rules, IFR, and I think you need AFR. You need autonomous flight rules. The the density is going to be greater than the separation standards that we are used to. And we have technologies that will allow navigation, sense and avoid, route optimization, things of that nature that will need to be incorporated into the NAS that currently just aren't able to be accommodated.
Mm. And historically, looking back at how long it usually takes for changes to take place in the national airspace system, those are measured mostly in decades. What gives
sometimes, yeah. I mean, it's certainly in years. Yeah, Datacom is being rolled out. You have to build out the physical infrastructure as well, and the control towers and the centers. All the air traffic controllers have to be trained and retrained on it. It's a fairly intensive endeavor, and again, safety is really the driving dynamic there.
Got it. It'd be interesting to take this perspective and see, well, if some of these changes don't really happen, can advanced air mobility still deliver on its promise?
Yeah, I think that's the question, and really, to me, it's a timing question. How quickly can you bring these elements together?
Mike, you entered the world of advanced mobility a few years ago with a really unique background, coming from the top levels of the FAA and United Airlines. Did you ever expect you'd end up in the automotive industry?
I don't think I ever expected that, but I'm happy that I did. I've always been a car buff from my early teens. I've always loved cars. Always, for decades, have subscribed to car magazines and watched development in some of the technologies in cars. And it's always, when I was at FAA, I was really curious about why you can, as a consumer, you can spend $50,000 on an automobile and get just an absolute marvel of technology. But in general aviation, you would spend 10 times that much and you would get 50-year-old aircraft design with a 75-year-old power plant, and why you don't have the kind of technology leaps that we've seen in automotive. So I think it's an interesting melding of industries.
What's your favorite car?
Well, I love the old James Bond Aston Martins, I guess. But I think all these old dream cars are out of the realm of the possible these days.
Okay. When you first joined the industry from Hyundai, what were your initial expectations, and how are they different today?
I think the intriguing thing about a car company like Hyundai coming into this space really comes to the vehicle design and bringing some of the best practices of the automotive industry to aviation from a design perspective, but also from a manufacturing perspective. Every aircraft on the planet is basically a hand-built vehicle. Hyundai has factories that produce thousands of cars a day. So if you can bring some of that manufacturing prowess to aviation, it would allow you to produce vehicles at a dramatically lower cost than anything we've seen in the past. That can be a real game changer if you get the cost of these vehicles down to a certain point. But it also speaks to the need to have high volumes of production, meaning business models that can support a large number of these vehicles on the market.
So speaking of that, the automotive and aerospace industries have many things in common, but they also differ in how they address certification and production standards and such. And there's a reason why aerospace production is the way that it is now. Technology is available, but certification and scrutiny on every component really dictates takt times in a lot of times. So in practice, how do these two worlds work together? What are some of the key sources of friction?
Well, I think you've correctly articulated it. There are very different quality standards, safety standards. There's just no room for error. When you're in the air, you can't pull over. So I think it's, for us, you start at the level of safety that you want to achieve. And, sometimes this technology is referred to as flying cars, but I think first and foremost, they are aircraft, and they have to meet the level of safety that has been demanded, not in general aviation, but in commercial aviation, in the airline industry, the 10 to the minus 9 standard, if you will. It's an incredibly high standard, but for those of us who've been around long enough, no one really thought we could achieve that level of safety in the airline business, but we did. So I think it's not only possible to achieve that, but I think it's necessary, because I don't think the public will ever accept this technology if it's not as safe as getting on a 737 or an A320 to take a trip.
Mike, what most energizes you about advanced air mobility, and what most concerns you?
Well, on the concern side, it's a daunting task to try to pull the infrastructure together in the right time. It's a very new industry and a lot of unknowns. So that's a challenge. It's an exciting challenge, but it's a challenge. I think the exciting thing here is the opportunity for a much better mobility experience. And if you think of the airline industry, its costs are very driven by the size of the aircraft. The bigger the airplane, the lower the seat mile cost. The cost for electric propulsion is really disruptive to that model. And I think it's going to create business cases that we can't even imagine at this point. But the ones that you can imagine someone living in an area, let's say a 2.5 hour drive outside of San Francisco. So in San Francisco, if the houses are, over $1 million on average in this community outside, they might be, $200,000 or $300,000. If that person could commute into San Francisco, it opens up economic opportunities and really becomes a game changer in the opportunity that's available for people. You can see effectively metro type systems in urban areas that give access to communities that previously didn't have access without the kind of infrastructure investment required to build a subway line. So I think there are a lot of great opportunities. And again, it comes back to getting the cost down and having it be available to a large number of people. I think that's key on a number of levels.
When you mention infrastructure, what comes to mind in the last couple of years since you've been with Hyundai that has to occur? Just the top couple of things in infrastructure that people should be aware of.
I think the vertiports are an obvious one, and you're talking about bringing the electric grid to locations for recharging. I tend to view the operational rules as part of that infrastructure. I view workforce training as part of the infrastructure. So, for example, now if you want to become an aircraft mechanic, you go through a very defined curriculum. The FAA has defined this curriculum. It's been around a long time. It involves skills like riveting, rebuilding carburetors, working on turbine engines, none of which has much to do with these new vehicles. So we probably need to have a different category of mechanic that works with composite materials and electricity and batteries and propellers and not traditional aviation. So that kind of infrastructure is part of this as well. You've got to have a network of MROs. Really, you're building an entire... It's like you've invented the car, now you have to build roads and gas stations and think about speed limits and all the issues that go with it. We have an entire new type of transportation that needs all of that infrastructure.
Back in 2019, Hyundai said that they would be investing $1.5 billion in advanced aerial mobility over the next 5 years. Now we're, fast forward 2 years. Is that still the plan? Do you see signs of acceleration or a slowdown?
I think that is the plan has not changed as far as Hyundai's commitment in this space. I think we've all been navigating COVID issues that have had some practical implications, such as opening facilities and getting people together to work on designs and those types of things. But the commitment is still there. The time frame is still there. And I think what we have seen since Hyundai made that commitment is several other car companies decided they should be in this space. So I think that validates the strategic direction.
Mm-hmm. And how is Hyundai thinking about the business model as an OEM or as an operator?
Well, I won't be able to go into too much detail about that other than to say that we have spent a lot of time looking at the value chain, the different pieces of the value chain, understanding where the value comes from around vertiports, around operations, around owning the passenger data, and all those, I think, are going to be important decisions that will get made over time.
Got it. Maybe this is a good time to ask about the value chain. When you think about the entire advanced air mobility value chain, what part do you think will be the most valuable?
When I was in the airline industry, people used to joke that everybody in the airline industry makes money except the airlines. And for a long time, that was true. The airlines have done better of late, but clearly we're going to be in the OEM space. Operators, I think that will be an important part of the value chain. There are limits on operations for foreign-owned entities in the United States, so that's an issue that has to get navigated. And I think the vertiports are a mystery. What kind of opportunities might be around vertiports? Airports can be very profitable operations. They're heavily regulated, but I think what happens at vertiports can also be an important piece of it. And I think another part of it is how it links with other modes of transportation, because you really want to be able to leverage technology to integrate this mobility option with other mobility options. So your rideshare showing up at the vertiport is coordinated so you don't spend a lot of time once you're there waiting to board your aircraft. So I think that's an important opportunity as well.
Mike, we are all proud of the safety record of the FAA and having the safest airspace in the world. What level of safety will be required in advanced air mobility?
So I think I know what level of safety should be required, which is 10 to the minus 9, which puts you in the same category as the airline industry. I think depending on how you define advanced air mobility, if someone is just owning a vehicle and operating it in the way you would operate a general aviation aircraft, then I suspect that'll be the standard of safety. But when you talk about the kind of dense operations that we would envision in urban environments, I think there's no choice but to reach that high level of safety.
Okay, so let's talk about the public perception for a second. What should the industry be doing in order to minimize the risk of the general public rejecting this technology?
I think the key is to have a mindset that favors engagement with the public as this technology develops and is deployed. So, for example, in traditional aviation, you have federal preemption, you have an airport that's its own little world, and you're only really needing to deal with the federal agencies to have an operation. I think with urban air mobility, you still have federal preemption over the airspace, but you open up a lot of land use issues. You open up a lot of equity issues as far as where service is going to be provided. So I think the only way to effectively navigate that is to engage early with cities, the various stakeholders in cities, to make sure they're included in the process. It's always easier to have meetings, town public meetings, with people before you've deployed a technology rather than after, where you're trying to explain why something's changed. So I think having ample engagement at the community level is going to be key.
What regulations need to change to make all this work?
So that's a really good question. And I think if you look at the different buckets of regulation out there, you start with the regulation of how you certify a vehicle. I think early on there were discussions around a new set of regulations that would just be focused on eVTOL, electric propulsion, vertiports, and the like. I think now the feeling is we have Part 23. The FAA deployed Part 23 6 or 7 years ago, and that is an adequate structure for vehicle certification. That's what the current vehicles are using to go through the certification process. So it's not perfect, but as the FAA issues special conditions, it can explain how they're viewing the process and kind of build out that regulatory system. So I think it's not a perfect system, but it's a workable system. I think when you get to vertiports, there just aren't sufficient regulations. So there needs to be new regulation, even just in the form of a advisory circular. We need to hear from FAA on what the expectations are on things like interoperability for charging facilities, for example. I mentioned workforce training. I think there's going to be a need for new regulations there. And of course, rules of operation for these new technologies will have to be developed as well. So those are sort of the four big buckets.
How does that regulatory landscape change across regions?
Well, I think EASA, the European agency, has, I think, been a little bit out and ahead of FAA in providing more clarity around their vision for certification and their vision for safety. They've issued guidance on means of compliance and other areas. For the most part, the US and Europe work pretty well together. There's maybe a little more tension following the MAX incident, but we would hope that there would be alignment and a close working relationship there. A lot of the rest of the world will follow the lead of FAA and EASA, sometimes literally just cutting and pasting regulations into their own regulations. I think all other key regulators, Canada, Singapore, Australia, Japan, but pretty quickly you run out of a need to coordinate. If you can get the major players lined up, then you've really sort of done your job.
Mike, you mentioned earlier potentially the value of real estate being affected by advanced air mobility. What other industries will be disrupted, do you think, by this technology?
I think it's almost impossible to say. It's like being at the advent of the personal computer and trying to predict the iPhone. It's really difficult to say. Personally, I would like to think that it creates travel options that can get you away from hub airports. The US has 5,000 public airports. It's a huge number of airports that largely sit underutilized, pretty dramatically underutilized. If you could push transportation options out to those airports and keep you out of the hubs, I think almost everybody would, perhaps except the hub carriers, would think that's a good idea. So I think it's a little early to tell, but with the disruptive cost structure of electric propulsion, and as the size of the aircraft grows, particularly fixed wing electric aircraft or hybrid electric aircraft, it can create an option for business models that we just haven't seen yet.
We've talked about the timeline and the infrastructure needs, and that being a source of differences of opinion in the industry. What other common misconceptions or misunderstandings about advanced air mobility, or some of the points that we discussed in the podcast so far? What do you see as some of the most frequent?
Well, I think you've hit on a lot of them, and I think that the topic of public acceptance is an interesting one. People have pretty strong feelings about flying. A lot of people are quite nervous when they fly. As you certainly know, Luca, flying a small aircraft is a very, very different experience than flying a larger aircraft. I'm not sure the public fully understands that, and I think there's some technology options to try to make the experience more acceptable. But if you think about an operation that runs perhaps to an airport, you would like it to run as much as possible and not be influenced by the weather. But there will be weather that is extremely uncomfortable for some flyers. Other flyers will be perfectly happy to fly in a bumpy, small vehicle out to the airport. People understanding what that's like and understanding that what the passenger experience is, I think is going to be a very interesting dynamic. I think it also raises some opportunities perhaps on technology around weather and forecasting. You're much more focused on sort of micro weather now and really understanding the weather on the entire route because you're staying at a relatively low altitude. So I think those are some interesting aspects that maybe haven't had enough attention.
Yeah, great points.
Mike, if you fast forward 5, let's say 10 years, or even further out if you'd like, what does the industry look like? And also, if I can add, what are going to be the most common use cases?
I hope that it doesn't start out as an industry that just caters to the wealthy, but a lot of technologies, that's the path, whether it's automobiles or airplanes. But I think what you'll see if you go out 10 or 15 years, I think you're going to see some cities that have been very forward-leaning and very welcoming, operating these types of vehicles as part of their transportation network. And so there'll be a bit of catch up. Some cities aren't really very interested at this point, but might become interested as they see other cities deploy the technology. And I think for the startups, whether it's Hyundai or another company, focusing your efforts on certain geographies is the right approach early on, so you can build out a transportation system consistent with your business model. So I think we'll certainly start to see those up and running and hopefully having some business success as well. But the early years may be challenging just from a cost perspective.
How do you look at the recent deluge of orders, or perhaps better called quasi-orders, that various airlines are placing with different eVTOL manufacturers? There's no commitment in these orders, really, and to many, it feels like just a PR effort at best. Is anyone taking them seriously? How does Hyundai look at them?
I'm going to try to be very diplomatic here. I think, we've seen this whole phenomenon with SPACs and the need to create buzz. And I think certainly orders create buzz, and you can see sort of a direct correlation between orders and enthusiasm for IPOs and the like. That said, I don't want to dismiss it completely. I think from an airline perspective, if you have a serious OEM startup, why wouldn't you want to have orders on the book, particularly if it's not costing you very little? There's not really a lot of downside in that. And I think from an airline point of view, it shows that you're concerned on the environmental front. And there aren't that many other ways to show your concern on the environmental front if you're operating, 777s. So it seems to be a symbiotic relationship between the airlines and the startups, which is why I think we've seen a lot of activity in that space. But I don't want to be overly cynical, because I think particularly as companies move closer to manufacture, you want to understand what your manufacturing targets are going to be. Those order books become pretty important.
Mike, with your FAA and airline background, what are going to be some of the best practices as it relates to airspace integration across the advanced air mobility spectrum, including drones, eVTOL, and the like?
I think it's going to be, I think the best practices for integrating new technologies is industry, government working groups, and processes that allow an exchange of ideas and sort of common problem solving. There's, I believe, a lot of opportunity in some of the new technologies that could be introduced into the air traffic system. Automation is clearly the direction. We're already seeing a movement now from voice communication to data communication in the air traffic system. I think that's an important transition that needs to continue, and we need to have more integration of autonomous systems and leveraging sensors for optimizing routes and deconflicting traffic. It's going to be a long process to do that, but I think the pieces are in place to have that happen.
So a lot of technology gates still need to be achieved and met, a lot of innovation that needs to occur. Why do you think entrepreneurs are attracted to this space?
It has so much possibility. It's a little bit like being at the early part of the personal computing industry. There are so many possible use cases. We were talking beforehand about ship-to-shore use cases for eVTOL vehicles that just create a huge efficiency and safety improvement if you can build up networks of ship-to-shore for cargo or even for passengers, for that matter. And as you look at our current supply chain issues, you can imagine that could be part of the solution for some of the supply chain bottlenecks that happen in ports. Public transportation networks, there are just really so many uses that are possible. And Lucas, I think you were suggesting some of these technologies aren't there yet, and whoever comes up with the ideal sensor or the ideal algorithm for deconfliction, it's an important business opportunity.
Mike, where should entrepreneurs be innovating? What are some of the more important remaining pain points to solve?
Well, I think the battery technology is an obvious place where there's a need for improvement, and I think a lot of companies chasing solutions in that space. I would say propulsion generally is an area where there will certainly be a lot of innovation in the coming years. The avionics piece, the automation, the holy grail, the artificial intelligence, and the ability to really leverage that technology to achieve that high level of safety that we are all striving for, but also allow the business model to be more robust as you reduce pilot input into these operations.
And what advice would you give to someone who wants to start a business in advanced air mobility?
Well, I often hear the number 250 as the number of companies that are trying to build electric flying vehicles. I don't know if there's any basis to that, but there certainly are a lot of people chasing.
That sounds about right.
Yeah, a lot of people chasing this technology. I think if I were giving advice to someone in a startup space, I might try to steer them more toward the components, because I think that's where there's going to be a lot of opportunity. And rather than betting the whole house on one vehicle, the components is maybe a way to spread that risk, but still participate in the space. But there are a lot of people working the issue in a lot of different ways, a lot of different business models. So it's a pretty exciting place to be.
We tried to, in anticipation and looking forward to our conversation, try to think of what questions would our audience want to ask of Mike Whitaker. Is there anything that we haven't asked you that you think we should be asking that you want to be able to talk to our audience about?
I think we've covered most of the interesting issues, and the ones that we have covered that aren't often discussed, I think, are the weather aspects, the passenger comfort in small vehicles aspects. One of my favorite topics, Jim, as you know, the leveraging the GA airport network. So I think we've covered a lot of ground.
If you had 1 minute to summarize your podcast for a listener, what would you say?
I would say it's really the discussion around what is advanced air mobility and what's it going to look like 10 or 20 years out there, and what are the big challenges on the ground level that are going to have an impact on how quickly this technology is deployed. And so it really comes back to your very first question on timing. What is the timing for this industry to come into its own?
Mike, thanks very much. It's great having you on the show.
My pleasure. Great to be with both of you today.
Thanks, Mike.
Thanks, Luca. Thanks, Jim.
All right, that's a wrap for today. Thank you for listening to the Vertical Space Podcast. Reach out if there are topics that you would like us to discuss, and goodbye until the next episode. Unless mentioned, this podcast is in no way endorsing or promoting any person and or company mentioned, and all opinions within the podcast are solely that of the presenters. The Vertical Space makes no guarantees, warranty, or representation of any information given in this podcast. Any information given is for informational purposes and should be used at your own risk. This podcast is for general, educational, and entertainment purposes only.